Hi everyone, in this video I'll be going through chapter 13 of the A-Math textbook of the chapter of tangents, normal, rate of change to go through the revision set B questions. Okay, so in this video I'll be focusing on the more challenging questions. I'll skip the very basic standard questions. So let's look at question B1 here. I'm given the equation of a curve as such. I'm given the normal to the curve at x goes to 1 and a line parallel to the normal to the curve. First part, show that k is equal to negative 26 over 81. Okay, for this question here, I have worked out the solution very quickly so you can double check. First step is to find what is the gradient of the normal. Once I found the gradient of the normal, I can now find the gradient of the tangent. Once doing so, I can now find dy over dx. Based on the equation of the curve here, I find dy over dx. Then, based on the information given by the question says that when x is equal to 1, the gradient of the curve is equal to 3 over 2. So if I were to equate this together over here to form this equation, I can then solve for k, which will give me k is negative 26 over 81. Okay, so this is for part 1. Part 2 is a very standard question. The question says, find the equation of tangent to the curve when x equals to 1, so I will not go through. I'll focus on part 3 here. Show that the curve is an increasing function for x is greater than 26 over 27. So what this question wants us to find is that, very simply, the question is asking us to show that when my dy over dx is strictly greater than 0, the range of values for x is strictly greater than 26 over 27. So I know that my dy over dx is given by this equation over here. Okay, and the question says, show that when this expression here is greater than 0, I can get this. So very simply, we just need to simplify this inequality. So to get rid of the half, I will multiply 2 on both sides of this inequality. So this will be x over 3 minus 26 over 81, how negative 1 over 4 greater than 0. Okay, then after that, I'll apply a power 4 to both sides of this inequality. I will get x over 3 minus 26 over 81 strictly greater than 0. Therefore, x over 3 is strictly greater than 26 over 81. X is greater than 26 over 27. Okay, and this is the solution to part 3. And this is for question 1. Okay, I will not go through question 2. I think this is a very standard question, so I'll be skipping this part over here. This is a very, very standard question. I'll move on to part 3 now. Okay, let's look at question 3. Okay, this question here says, find the, given that a function is defined by this expression over here, find the range of values for p such that fx is a decreasing function. So we highlight some key terms here first. Let me write my fx down so that it's clear. Fx is equal to negative 2x cubed plus px squared minus 6x plus 3. So using this function here, I can immediately find an important information, which is f prime x. The differentiated form of this function is simply negative 6x squared plus 2px minus 6. Okay, so for part 1, what the question is asking us to find is that find the range of values for p for which fx is a decreasing function. So to understand the question, for fx to be a decreasing function, to be decreasing, it means that the f prime x, the derivative of this function, f prime x should be strictly less than 0. Okay, so from here, for this, therefore this means that negative 6x squared plus 2px minus 6 is strictly less than 0. Okay, so therefore what this means is that, imagine if you still recall your quadratic inequalities, this expression here is a set face curve. Because this coefficient of x squared is negative, this is a set face curve. How do I solve this quadratic inequality? It means that this set face curve here is always less than 0, meaning that it's always below your x-axis. So which means that, how do I solve this quadratic inequality? If you still remember the chapter, this means that if I were to equate, therefore this implies that the equation negative 6x squared plus 2px minus 6, if I were to equate this curve to the x-axis, this equation has no real roots. Okay, so if I were to illustrate it out over here, okay, let me add the illustration here. Okay, so this part here means a set face curve. This is your x-axis. This means the set face curve lies below your x-axis. So if I were to draw x-axis like this, okay, this curve lies below your x-axis. Okay, and therefore, this is my curve. This is your x-axis. Okay, so this means that if I were to equate the equation of the curve to the equation of the x-axis, there should be no real roots, which means that the discriminant of this quadratic equation is strictly less than 0. So therefore, if I were to write out over here, this means that therefore, discriminant of this quadratic equation is strictly less than 0. Okay, so therefore, if I were to understand this from here, discriminant is b squared minus 4ac. My b is 2p. Okay, so over here, this will be 2p squared minus 4 times negative 6 times negative 6. This is strictly less than 0. Okay, then from here, I continue to simplify. I'll get 4p squared, okay, then minus 4 times 36 is strictly less than 0. I will get p squared minus 36 if I were to divide by 4 throughout. This is strictly less than 0. So by factorization, I'll get, this is a squared minus b squared. This will be p plus 6 times p minus 6 less than 0. Therefore, to solve this quadratic inequality, I draw, this is a smiley face curve. The intersections to this smiley face curve are negative 6 and 6. Okay, so therefore, less than 0 means that, if I were to sketch out, less than 0 means I want the part of the curve that is below your x-axis, which is this part over here. Okay, so therefore, final answer is simply p is between negative 6 and 6. And this is the solution to part 1. Okay? So this is for part 1. Alright, so part 2 wise, part 2 is another very standard question. All you need to do is to sub in your p here to become 4. Then find the equation of the normal. You can find the equation of the tangent first, then find the gradient of the normal. Okay, find gradient of tangent, then find gradient of the normal. Then you can find the equation of the normal. So this question, part 2 is very straightforward, so I will not go through this part. Okay, so let's now look at the next part here. Question 4. Okay, for question 4 over here, I am given this curve here. Okay, for this curve over here, if you read this question here, I'm given this curve here which has the equation y equals to x squared. I know the point R and point P. Okay, and this point, this variable point P moves along the x-axis, and that means that this point Q here, such that PQ here is always parallel to the y-axis. Okay, so the first part of the question says find the area of the triangle PQR. Okay, if PQ is always parallel to the y-axis, we know that this angle here must be a right angle triangle. Okay, and for the area of any right angle triangle is simply half times base times height. Okay, so if I know that point Q here lies on this curve, okay, and the x coordinate of point Q is equals to the x coordinate of point P, which is equal to P. This means that my point Q here, the coordinates is simply, the x coordinate is P, and since point Q lies on the curve over here, if the x coordinate is P, when x is equal to P, the y coordinate is P squared. Okay, so therefore, to find the area of this triangle is simply half times base times height. By this diagram over here, I can see that the length of the base is simply over here. This distance here is 1. This distance here is P. So the base is simply 1 plus P. And the height is simply P squared. The y coordinate of P, of Q. Okay, so therefore for part 1, very simply, let me draw at the side. Area of triangle, PQR is simply half times 1 plus P times base times height, which is P square. I simplify everything, I should get half times P square plus PQ. Okay? Or you can also write this as, let's say, half P square plus half PQ. Both are equivalent. Okay, so over here, this is area A. The question is capital A, letter A to define this area. Part 2. If P, this x coordinate here is increasing at a rate of 3 units per second. So that means that this question here is telling you that since P is a variable, dP given from this information over here, P is increasing at a rate of 3 units per second. This is telling us that dP, the rate of change of P with respect to time, is equal to 3 units per second. Okay, I want to find the rate at which A is increasing. So the question is asking us to find the rate at which A is increasing, which is referring to dA over dt. Okay, so I know that by my connected rate of change, I know that dA over dt is simply equals to dA over dP times dP over dt. Okay, I want to find this. I want to find this. I know what is this. Now I need to find what is dA over dP. So I look at part 1. I'm given A, and this expression here is all in terms of the variable P. So very simply, since I know that from part 1, A equals to half P square plus half P cubed dA over dP is simply P plus 3 over 2P square. Okay? So therefore over here, the question says find dA over dt when P is equal to 5. So very simply, when P is equal to 5, dA over dt is simply dA over dP, which is here. But I will sub in P equals to 5. This whole thing over here will be equals to 5 plus 3 over 2 times 5 square. This whole thing times 3. Okay? And therefore, if you were to evaluate this using a calculator, you should get 127.5 units square per second. Okay? So therefore, to answer the question, therefore, A is increasing, since my dA over dt is a positive, is increasing at a rate of 127.5 units. 127.5 units per second. Okay, and this is for part 2. Okay, and this is for question B4. Alright, so now let's look at B5 now. Okay, B5 here, this is a very unique question. I'm just given words. So I have drawn this hexagon. I hope you know what's a hexagon. It means a 6-figured shape. Okay, of side 4x cut into 6 equilateral triangles. So I have drawn these equilateral triangles over here. Show that the area of the hexagon is given by this expression here. So all these are equilateral triangles. Equilateral triangles means that all sides are equal. Okay, so how to find area of triangle? I hope you still remember. In E-math, you learned that. Let me write it down over here. Area of one triangle. It is simply half AB sine C. I know that in a hexagon, in an equilateral triangle, all the angles are 60 degrees. And in this case, all sides are equal, all sides are 4x. Okay, so therefore, to find the area of one triangle, this is simply equals to half AB, which is 4x times 4x, then sine C, which is sine 60 degrees. Okay. Therefore, from here, this is simply equals to, I simplify this, I should get 8x squared Sine 60, this is a special angle. I hope that you can see that in exact value, this is simply equals to root 3 over 2. Okay? Therefore, one triangle is simply equals to 4 root 3 x square cm square. Okay? This is the area of one triangle. So therefore, this is part 1. Therefore, area of hexagon, they tell you that the hexagon is made out of 6 equilateral triangles. This is simply 6 times 4 root 3 x square. Final answer is 24 root 3 x square. Okay, there we put the units. This is the whole thing is cm square. And this is for part 1. Alright. So now, let's look at the next part. Given that A is increasing at a constant rate of this, so we are given information by the question, I would like to write it down to be clear. Given dA over dt is equal to 6 root 3 cm square per second. Find rate of increase of x. The question is asking you to find, let me write it in red, find dx over dt. Okay, so over here, I can first form, I know that given this area of the hexagon here, area of hexagon is defined as A by this question, A. So I can call this A. Okay. So therefore, if I can form my connector rate of change equation first, I know that dA over dt is simply equals to dA over dx times dx over dt. Okay, I know this information. I want to find this. So now I must find what is dA over dx first. A is given by this equation over here. Therefore, dA over dx is simply differentiating A with respect to x over here. This will become 48 root 3x. Okay, so therefore, when x is equal to 2, okay, maybe I write this at the side. Okay, I write this over here. Okay, therefore, when x is equal to 2, then I can sub in the values now. dA over dt is 6 root 3. 6 root 3 is equal to dA over dx is given by this here. I sub in x equals to 2. This will be equals to 48 root 3 times 2 times dx over dt. So therefore, very simply, dx over dt is equal to 6 root 3 divided by 48 times 2 is 96 root 3. Simplify everything from here. Okay, simplify everything from here. This is simply 1 over 16. Okay, and the units for dx over dt is equal to cm per second. Okay, don't forget about the units. Okay, so therefore, final answer to this question is simply, therefore, rate of increase, since dx over dt is positive, rate of increase of x when x is equal to 2 is 1 over, this one should be 1 over 16, sorry, I didn't write the 16 there. Okay, 1 over 16 cm per second. Okay, and that is my answer to question 5. Okay, alright, let's move on. Question 6 is a very standard question and was gone in your worksheet when we did this chapter, so you can refer back to your worksheet for this question. I will not go through this question for this video. Okay, let's now look at the last question, which is an interesting question, which I've drawn out the diagram for you to better visualize this question. Okay, B7, okay, the minute hand of a clock is 10 cm long, so meaning that if I draw the minute hand out, this is 10 cm. Okay, it completes one revolution. One complete revolution means it turns one round like this in 60 minutes. Okay, so over here, from its position at midnight, the minute hand turns through an angle of theta. Find the rate of increase of theta, meaning that find let me write it out clearly. Question wants you to find rate of increase of theta. The question is asking you to find the theta with respect to time, meaning that find the change in angle every second, for example. Okay, so very simply we know that or every minute this is dependent on the whatever information we use. Okay, we know that for this part over here, okay, I will use radians. I'll use my angle in radian measure. Let me write it out clearly. Use radian measure for angles. And you will notice radian measure is much easier because of your formulas for circles in radian. So I will use radian measure for this. Okay, so part 1. Okay, I know that this d theta over dt, I know that this minute hand, it turns one whole round in 60 minutes, which means that one whole round, the angle it makes in one whole round is one full circle, 360 degrees. And that's equal to 2 pi radian. So I can write this as 2 pi radian. And it turns 2 pi, one full circle in 60 minutes. Which means that my d theta over dt is simply equals to pi over 30 radian per minute. Okay, so therefore, if I were to write this in words, therefore, rate of increase, the angle of theta is pi over 30. It turns pi over 30 angle or radian per minute. And this is for part 1. Okay? Now for part 2. Let's look at the question. Starting from the position of the minute hand at midnight, what is the rate of increase of the area of the sector swept out by the minute hand? So if you were to notice, over here, this is the sector. Okay, and the question wants you to find the rate of increase of area of the sector. So if I let this sector area, I call this part 2, let sector area swept by minute hand be A. Let this area be A. So that is clear. We know that based on your formula you learn in E-math, okay, formula for sector area is equal to half r square theta. Okay, see, if I use a radian measure, the formula is much easier to use to find sector area. Okay, and I know that the radius of this over here, the radius is 10 cm. Okay, so therefore the sector area is simply half times 10 square theta. Sector area is simply 50 theta, depending on the area swept out by the minute hand. Okay, so okay, so the question wants us to find the rate of increase of area. Essentially, we are supposed to find dA over dt. Okay, so that means that if I were to form my connected rate of change equation, I know that dA over dt is equal to dA over d theta times d theta over dt. Okay, so I'm supposed to find this. I need to find these two information here. This is found in part 1. How do I find this? I look at this part here. A is given by 50 theta. Therefore, from here, okay, dA over dt over d theta is equal to 50. Therefore, final answer. Therefore, dA over dt, the rate of change of the sector area, is simply equals to 50 times d theta over dt, which we have found in part 1 to be pi over 30. And therefore, final answer is simply 5 pi over 3 cm square per minute. Okay, so therefore, to answer the question, therefore, rate of increase of the area of sector is simply 5 pi over 3 cm square per minute. And with that, we have come to the end of this video. I've gone through all the challenging parts of this chapter revision set B. So I hope that you have learned something from this video.